Hi, welcome to the second guest lecture for Intro to iOS. I'm Justin, and today we're going to be talking about animations, and just generally how to make your apps look fun and pretty. So here's the general rundown. First, we're going to go over just very quickly why we want to use UIView animations, and then I'll go into a bit more detail in the functions, specifically in what you can do and how you can kind of string them together to kind of create these really cool emergent effects. And finally, I'll show you these animations in action in a small demo app that I threw together. And so why would we want to use UIView animations? So here, let's quickly see a demo of someone using eatery. So here they reload, and you kind of see this rolling circle, and then they scroll down, and then they tap on eatery, and it kind of expands. So we can see that well thought out animations are actually very powerful in kind of giving feedback to specific user actions, but also you want to say focus the user's attention on specific parts of the app. You can do so really easily with animations. And these are really practical reasons, but it could also just be for fun, right? If you just want to give the user a fun experience, you kind of have your views moving around. Just makes the entire experience of the user a lot more fun. And compared to how much life these animations add to your app, they're actually really surprisingly easy to implement using UIView animations. And we're going to look at that right now. And so with UIView animations, you can actually only animate 6 properties: the frame, the bound, the center, the transform, the alpha, and the background color. But that's actually a lot. The frame and the bound are kind of just like this rectangle that boxes in your view. But the difference is that the frame refers to this box in the parent's coordinate system, and the bound is the view's own coordinate system. The difference is actually pretty nuanced, so if you actually are interested, you can read Apple's official documentation, but we won't actually be using this in this lecture, so you can just ignore them for now. The center is just the center of the view. The transform is actually a bit more complicated as well, but we will be using this a bit more, a little bit later in about 20 minutes, so I'll defer that to later. And the alpha is just the opacity of the view, so if you want to make a view kind of fade in and fade out, that's what you will be editing. And finally, the background color is just, the background color, and you can animate that too, which is nice. Cool, so how do I animate these views then? And here is finally where we introduce the UIView.animate function. And so what you pass in is just a duration, which is in the form of a time interval, but you can just pass in a float and it just courses over. And this is with respect to seconds. And the animation, so over here you pass in a closure, and what you want to do in the closure is you define the end state of what you're animating. So here is a quick, a good segue to our demo. Cool, hi. So this is the little demo app that I threw together. Here we have a ball in the top left corner, and we have 2 buttons here. So this code is also going to be uploaded to the website. So actually, I highly suggest you to download it and follow along as we kind of implement things. But I'll just quickly go over the structure of this. You don't have to pay too much attention to the template here. What is actually really, really important is just these 2 functions down here, which kind of actually is where most animation is going to be happening. But just for clarity, here is just a function that returns a UI view that represents this ball here. And I made a function because later on I'm going to be making more balls of different colors. So I just have it take a color as a parameter and then return a view. And so I don't have to write these attribute setting a bunch of times, which is nice. This ball stack is just so that I can, when I'm adding balls to this to the view, I don't have to manually set the constraints, which makes life a lot easier. The start and reset button, not very interesting, just the buttons. This is more setup. And this actually, if you watched Noah's lecture on tips and tricks in Xcode, is a way, say for example, we have a lot more balls, which we'll be creating later. If you want to set the same property over all the balls, you can put them in an array and just map over the array, right? That's a neat trick you can learn. And this is more setup of the buttons, some constraints, and now we get to the interesting part. So here, this start animation function is mapped to this button here. So when I click on it, right now it does nothing because, well, there's no implementation. But here is where we can start to animate this ball up here. So following the structure here, UIView.animate. So that's what we want to do here, UIView.animate. Taking this one. And over here we pass in the duration of 2 seconds. And here we pass in a closure. So what this closure represents is the end state of the animation. So say, for example, I want to move this ball over to the right by 100 pixels. So this ball is called ball 1. And so I would say ball 1 dot, say, for example, the center, right? So here's where we would use the center property. Add 100 to it. So that's the end state of my animation. And build, and right. Since this is a closure, right, and we're referring to something outside the closure, which is kind of with respect to this view, we actually need to add self.ball, right, to make sure that Swift knows that we're referring to specifically that ball. And if we build this, and click on this, hopefully, as you can see, in the matter of 2 seconds, the ball moves over by 100 pixels. And we can count it again, and again, and it just keeps moving, right? And again, and oh wait, like, it's gone. And how do we bring it back? Or we can think about it as like, how do we undo this animation, right? First attempt could be over here, say we're adding 100 to its center, right? So what if we say we subtract 100 from its center? And you can feel free to try this, but unfortunately this doesn't work. And the reason why is because in this closure, we're defining the end state of the animation. And so the end state of the animation, if we kind of define it like this, would be first move it over by 100 to the right, then move it over by 100 to the left, which means the end state is just where it started, right? So you're actually animating nothing. So this doesn't work. And say, for example, if we do something like this, right? So over here, we know that this animation moves the ball 100 to the right. So if I kind of just do the same thing, but I change it so that I minus 100, I'm animating it 100 to the left. So hopefully this works, right? But actually it doesn't. Unfortunately, what you're doing here is kind of equivalent to say like you're pulling a ball in both directions of equal force, right? So what's happening here is that you're animating it kind of like over 2 seconds, it's moving to the right, but also over that same 2 seconds, you're moving it to the left. You're kind of like pulling it in both directions, right? So what ends up happening is that the ball just doesn't move, right? So we're stuck, right? And what we want to do here is we want to have another animation kind of happening, right? Or like some block of code run at the end of this animation, right? And so that's where we introduce the second parameter, oh, sorry, not second, the third parameter of a completion. And it's actually really powerful because we can do a lot of things, as we can see here. So first, just solving the immediate problem of bringing the ball back, right? So we can, again, use UIView.animate, but this time we're doing the one with the completion. So let's give it the same time frame of 2 seconds and give it the same animation closure of self.ball. It's like the end state of the animation, right? Add 100 to the center, so move it right by 100. And now in the completion. So quick trick, if you press enter, it'll kind of autofill with some structure, which is nice. And this closure, this completion closure, takes in a Boolean. You can call it finished. Oops, sorry. Okay, there we go. And the code, this is like the body of the code when it runs the completion. Sorry, the closure. So this parameter that it takes in is actually a bit more complicated than it seems. So I call it finished, but what it actually is well, yes, okay, it is finished. So it's a Boolean value that represents whether or not your animation has finished. But finished is, like say, for example, at the end of the time you reach the end state. That's what finished is defined as. But it is possible for your animation to have to be paused or like to stop animating, right? But it's not finished. And that's when you say you interrupt the animation. And that's like a little bit more complicated than we actually need to delve into in this lecture. But just keep in mind that when you're kind of using this completion of the animation, if you know 100% sure that you never pause your animation at any point or interrupt the animation, then you can just ignore this. And you just run, right, whatever closure you want to run at the end of the animation, right? So over here, what we want is we want to move the ball back by 100. Right, and just to reiterate, right, you can only do this if you're 100% sure that you're not going to pause the animation and you're not going to interrupt the animation, right? But if you are, then you're going to have to use this closure and just make sure that your completion closure only runs if your animation has finished. So we do something like this, right? But like, since we're not, we can just do this, which is nice. Cool. So let's build this. And if all is well, what we should see is the ball moves 100 to the right and just goes back. Cool, that's nice. So let's make things more interesting. So let's say I move it 100 to the right, but I also want to move it down, for example, right? So center, I'm gonna move it center by 100 as well. Actually, no, let's make it 200, right? So if I want to undo it, I want to kind of bring it back, right? So I will also need to undo this. And what if I say I want to change the opacity, right? Remember, we can change the opacity of the ball. Ball dot opacity, layer dot opacity is equal to say 0. And then I kind of need to bring it back to 1, right? A bunch of different features. Also not features, sorry, animations. Let's see if they all work. Right. So you see, we made a mistake here, right? And well, of course, instead of adding 200, I should have minus 200, so that's a mistake. But we can also see how this can get really like annoying, right? Where every animation we write, we also can have to undo it. And it's possible that, say, math is hard, you do a lot of like complex rotations or whatever, and then like, you miscalculate the original state to send it back, right? So there's actually an easier way to kind of undo the animation. And that's where we introduce another way of kind of animating these properties. Instead of just setting the center and the opacity directly, we can use this transform property. So we can do self.ball transform is equal to, let me quickly just see what I said before. Okay, cool. So I'm going to set it as CG affine transform of translation of, I'll explain this later, but say 100 and 200. So, wait, let's make it build first. Nice, okay. So this kind of just encapsulates what we did just now, just in one simple function, right? We have a transform that moves it 100. So then this is, if it's a positive value, it moves to the right. Negative value moves to the left. Over here, if it's a positive value, it goes down, actually, I think. If it's a negative value, it goes up. But I guess we'll see that later when I run it. And yeah, so this is nice, but what's the best part of using transforms as opposed to using moving the center directly is, one, it supports a lot more things. So you can do rotations, you can also do scaling, right, which just moving the center can't. But when you're resetting things, it makes life a lot more easier because you have what we call a identity. So in the closure, all you have to do is you do CG affine dot identity. And so this just kind of undoes your animation at the end. And you say you do a bunch more animations, so you want to do transform here, but you also want to change the opacity. So over here, I would, actually no, so I take that back. You can't change the opacity here because opacity is not a form of transform, so it won't actually undo. But what is a form of transform is, say, the scaling. And so here, when you're using transform, what you can do is you can do dot concatenate, and so you can add another transform. And so you transform, say, now I want to scale it. I want to scale the x and y by, say, 2 and 2. So I kind of double the size of the ball. So let me just put it down here, move it over here, here, okay. So these are two transforms that I'm using, right? And as we see here, after I build and run it, so what we expect is the ball to kind of translate by these two values and then scale, become bigger. And oh, I think that's actually going up. So let me do negative 200. Let's try that again. And there we see, right? So so this is why you want to use transform a lot of the time instead of using and just moving the center directly. And so I actually did not think this through properly, but I chose to use balls here. But now I want to show you how to rotate the ball, but I guess it doesn't make a whole lot of sense. So what I can actually do is I can scale it so it's no longer a ball, but an oval, and then I rotate it. And over here, just quick thing is that over here, the rotate value is in terms of radians. So you want to say, if I want to rotate it by 90 degrees, you would need to pass in pi over 2. Oh, did you not take pi? Okay, let's just do 3.14 then. And then divided by 2. Cool. Dot. Okay. There. And see, it kind of rotates like, oh, let's do it again. Right, as it's transforming. And you can see a lot of potential in this, right? You can, do a lot more transforms, a lot more scaling. You can also do what we call shearing. And you don't have to remember like the math of what you did, right? You just set it back to that identity. So that's pretty cool. So one thing I'm sure you've noticed is that each time when I'm doing these animations, I need to keep clicking on this, right? And that's fine if it's just this single animation, but what if I want my animation to be part of, say, of like a loading screen, right? It just keeps going on and on and on. I don't have to keep clicking on it. Or what if it's part of like a background, right? Like say a ball bouncing in the background. You can't have the user keep clicking on that. So what you want to do is you want to have this animation loop forever. And there's actually quite an interesting hack in how you want to do that is you could say, for example, have two functions, right? And in the completion, you have function 1 called function 2, and in function 2's completion, you call function 2 would then call function 1, and it'll just bounce back and forth. But there's actually an even easier way of doing that, and that's where we kind of introduce two more parameters of delay and option. And here what we can do is we can pass in, over here, you pass in a delay of, say, 0, and you can pass in an option array, which takes in a bunch of different values, and one of them is repeat. So repeat, and okay, so there's an issue. Incorrectly relayment options. Sorry, and cool, nice. Xcode is happy. So what repeat does is basically exactly what I described just now. It just keeps going, right? So after it runs your, after your function, your animation is finished, it runs to completion and it goes again. And so if we build this, we can see that after it animates, it bounces back and it goes again, and it goes again. And this is exactly what we want to do. And the options parameter actually does a lot more, but we don't have the time to go over all of them, but I'll quickly mention a bunch of other ones. So auto reverse is another interesting one that you might want to check out. Is instead of having to like reset it by an identity, say if you're going to change other properties like the opacity or other things that don't fall under transform, then you can also use auto reverse as a form of kind of defaulting your animation back to what it was before. And it actually has an added bonus of in fact, not only does it bring it back to the original state, it also kind of reverses the animation. So over here, if we were to use auto reverse, let's just see, it would actually, sorry, this wouldn't run because I need to get rid of this closure first. So allow it to kind of revert. So I'll just put in like nil here. No, okay, not compatible with real time void. I'll just put nothing here then. So what we should see is that as it animates forward, it also will animate itself back. That's auto reverse. See? Very cool. So yeah, and there's a lot more other things you can pass in. So another thing we notice is that this animation is not linear, right? So it kind of is like speeding up and then slowing back down, speeding up and then slowing back down, right? And so over here you can pass in other types of properties. So if you want, namely, is ease linear, ease in and out, ease out. And if you actually want to get really fancy, you can, let me see if I still have it here. Yes, you can do what we call a Bezier curve, where you can define a custom, speed up or a custom, I guess like animation rate that you want your animations to obey, and just pass it in, and you can set it customly. This is getting very fancy and advanced, but you know that this is an option that you can explore. Cool. And this brings us to the final part of the lecture, where we finally see all these animations live in how you would actually use them in, say, an actual app. So right now we've just, up to this point, we've just been seeing me animate these balls left and right, but how would I actually use them in, say, like a collection view? So here I have like a very bare bones app of just a collection view of cards. And what I want to do is show you how I would animate the cards when this collection view appears. So let me just quickly go back to the demo. So yeah, let me go out of this. And so what I actually did is, oh, not this one is, oh, okay, there we go. So I set up the demo in terms of like having a base navigation controller. So when you download this, and just make sure you delete that. So this is demo 1. If you click on it, it will push to demo 1. But now we're going to go to demo 2. So when I push to the car view controller, you'll see that they kind of appear in a staggered manner at random. Right? So that's what we want to do here. Okay. So when you guys download the code, it won't actually look like the completed version, but it would look like this. Where we have the animations removed. And what we're going to do right now is kind of work through in how we want to implement it. See, so it would look like this by default. And it's just, as I scroll down, it's just the same cards just over and over again. Okay. So let's look at the code. When you download it, it'll look like this. So all this like boilerplate stuff is going to be given to you. This is just, hopefully this should be familiar from the collection views lecture. I think Amy showed it in terms of these star, triangle, umbrella, like the Squid Game cards. But this is basically the same thing, just, you know, some cosmetic differences. So just as a quick refresher, right, this is the class of how we want to represent each of these cards. This is the collection view cell, where we kind of lay out specifically what we put in each of these cells. And finally, this is the overall view controller. We're setting up the delegate, setting up the data source, etc., etc. But we're actually, the focus of this lecture is not any of this code here, but it's how we want to animate how we want to animate when the cells appear. So what we want to be overriding here is, let me just double check. Yes, this is the views will appear part. So over here, we would want to override the view will appear. And so of course, when we override these things, first thing we do is just call the super function. Whatever it needs to do, it just does it first. And then we will do our animations here. So animate here. Okay, cool. So in order to animate these cards, right, we need to get, first of all, what these cards are, right? Because you know, ideally in terms of like a real life scenario, right? Say I have like thousands and thousands of pages of data. I don't want to animate everything if I can't even see them, right? Like over here, if I were to animate all the cards, even the ones off screen, it would make my app really, really slow. So I only want to animate this 1, 2, 3, 4, 5, 1, 2, 3, so these 15 cards. So how I do that is, actually, sorry, before I even do that, I will like want to encapsulate what I'm doing here into a function, right? Because I don't want to just like shove it all here. So I'm going to call a function. I'm going to call it animate collection view. And over here, I'm going to call it, so animate collection view. And we'll see why later. Okay, cool. So when I call out animation collection view, the first thing I want to do is I want to get specifically what cards I can see, or sorry, what cells I can see. So that would be collection view, collection view dot visible cells. And that will return all the cells that are currently visible, a very nice property. And just like to quickly reiterate, this collection view is what I defined up here, right? This is this collection view that we're seeing here, okay? And so another quirk when dealing with any type of like table, collection view, or other type of like an external view controller, right? Is you want to make sure that your data is up to date. So over here, before we even get the cells, we want to make sure that we have reloaded it. Reload data, reload data. And we also want to make sure that we also have the collection view layout if needed. And so this is actually really important because sometimes when you're reloading the data, not all the data has been loaded. And so when you call visible cells, this might return 0, right? You might be unlocking, you get 0. So this ensures that everything that needs to be laid out in your screen will be laid out before you kind of check whether or not cells are visible, right? Because it's possible that the cells have not been laid out, but they're there, right? But since they're not laid out, they're not visible, right? So just make sure that everything is going to be correct. Cool. So now we have cells representing all the cells that we can see, and we want to make sure that we animate them. So let's take a moment and think about how we want to animate this. So just now, when we, if you kind of like scroll back, like I think it was like 2 minutes ago, when we saw it, what happened was that it was kind of like going up. So the animation was going up, right? But they were kind of fading in. So we can't just directly do that animation of translating it up by like say 20, right? And turning its opacity from nothing to something, right? I think it's 0 to 1, right? Because the initial value of this cell, its opacity is 1, and it starts off exactly where it needs to be. So in order to do that animation, we need to move it down first and then move it back up, right? And this is a very common trope in animations, is that it has its initial position, but I want to make it like end in its initial position. So I move it away and then I bring it back to its original position, okay? So that's what we're gonna do here. So I'm gonna loop over all the cells. So for cell in cells, cell.transform equal to CG affine. So over here, right, when I'm doing these translations, I don't mind using CG affine because it makes life a lot easier, right? Remember, we have this identity function that lets us kind of bounce back, right? So I translate x by 0 because I'm not moving it left and right, I'm only moving it up, right? And move it by, say, 20. And actually, so we don't like magic values. We just gonna, I want to make sure that I define it. So later on when I'm changing it, I only have to change it in one spot. So I'm going to define this variable called y offset. It's going to be of value CG float, and what is value of 30. So over here, instead of just putting a magic number, I'm going to translate it by a y offset, a fixed y offset. Cool. Now, then I want to have it fade in, right? So remember, transform doesn't deal with opacities, so you kind of need to do it separately. Opacity, and I'm kind of making it start off as being invisible, right? So here, it has its original position here, but I want to make it start off like down here, for example, right? And again, over here, I want to start off as invisible. So I'm going to call this init position. Now it's in its initial position. I want to animate it back to its position that you want it to be, right? Okay, yeah. So you're moving its initial position and you're animating it back. So over here, again, I want to iterate over all my cells and animate them now, okay? So I iterate over all my cells and I want to transform them back to the original position. So that's where our fine identity comes in very handy. And I want to make it visible. Cool. And then, of course, I want to wrap this in a UI view animation. Sorry, UI view animation. Let's take this one for now. With duration of, say, actually, how many did I say? 1 second, right? I said 1 second. Cool. Delay of 0 for now. Option of nothing for now. Animation. So this is actually what this is supposed to be. Again, this is the end state, remember? Let's indent this. Okay, just cool. And then now the completion is going to be nothing. All right, cool. So let's see if this works. Demo 2. Nice. So all our cards are being animated, which is great, right? We see kind of they all start off faded and they kind of come up. But that's not what we want to achieve, right? We want to have them staggered because that looks really cool. And if we think back to the UIView app, we see that, you know, not all the views come out at the same time. They appear in a staggered manner. So how do we do that, right? And that's where the delay comes in. And that's kind of what we put off all the way up to now, is we can kind of use this delay to make our animation look a lot more cooler with this staggered effect, right? So what we want to do is that we don't want them all to appear at the same time. So for what I'm going to do is I'm going to create a delay counter. counter of 0. It starts off at 0. And the idea is that as I'm iterating over the cell, I'm also increasing, var delay counter of 0. And as I'm iterating over my cells, I'm also increasing this counter. So delay counter plus equals 1. And I'm using this delay counter to decide how long my animation should wait before it actually happens, right? So delay counter times, say, a small number of 0.05, right? Because you don't want them to be too sparse, right? You don't want the cards to like, have one appear and then nothing else appears and another one appears, right? You want to kind of like be offset by a little bit, so let's use a small number here. And now let's see what it looks like. And if I run the demo, as you can see, looks very cool. All right, so I think that's all I have for the demo for this. Yes, so let's move on to some action items. I think this should be coming out during Thanksgiving. So, actually no, this is on the Monday, so right before Thanksgiving. So your action item is just to enjoy the break. Take some rest, well-deserved rest after this long semester. And I hope you enjoyed today's lecture about animations.